AP Cram, Calculus AB, Free Response Exam Review. Question 38, Implicit Differentiation. Train A runs back and forth from an east to west section of railroad track. Train A's velocity, measured in meters per minute, is given by a differentiable function, VA of t, where t is measured in minutes. Selected values for VA of t are given in the table above. So here are selected values for VA of t. Okay, so this is the riddle we're going to solve. A second train B travels north of origin station. At time t, the velocity of train B is given by Vb of t is equivalent to negative 5t squared times plus 60t plus 25. And at time t equals 2, the train is 400 meters north of the station. Find the rate in meters per minute at which the distance between train A and B is changing at time t equals 2. All right, not gonna lie, this problem is a bit challenging because you have to compose several pieces of information to find the rate at which the distance between train A and B is changing at time t equals 2. Basically, they want the derivative at time t equals 2, but it's a little tricky. So this is a really good example to introduce you to the types of problems where you have to compose several pieces of information. A lot of people know where and how to begin, so I'll give you a moment to formulate your answer. And for those of you who are a little bit unsure, that's completely normal. The solution's coming up in a sec, all right? Okay. All right, so basically what we're going to do is we're going to let X be train A's position because we're told that it travels from east to west. So let's draw this out a little bit. So this can represent train A traveling from east to west. And we know that T is also on the horizontal axis. And this can be origin station, okay? And we're going to put a vertical in here. And we can let Y equal train B's position. So X for A and Y for B. And Z can be the distance between train A and B, okay? So Z is the distance between them. And just pretend that this diagonal that I just drew is perfectly straight. Note this is not drawn to scale. But notice what we have here. We have a right triangle. And if we know the distance of Y and the distance of X, then we can definitely figure out the distance of Z if we were to opt to use the Pythagorean theorem. So that's like the next place we should take this solution. So if we know Z squared, or even if we don't know Z squared, we know X squared plus Y squared equals Z squared. All right, so then we can easily solve for Z. Therefore, we can also take the derivative of this entire theorem, Pythagorean theorem, and within it is hidden the rate at which the distance in meters between A and B is changing, all right? And then we can plug in time t equals 2. So that's essentially the basis of our answer. We just need to kind of unlock it. Okay, all right, so let's take things up a notch. Therefore, we already know from an earlier problem in this series, I think it was probably, let's see, flashcard set either like 30 either 34, 35, or 36. I don't know. Just check. We were told before that x equals 300 at t equals 2. So that's a bit of information that we have in our pocket from before. Now we're told that at t equals 2, y is equivalent to 400, okay? So using the Pythagorean theorem, 300 squared is going to give us like what? 9,000. 400 squared is going to give us 16,000. So when we add those together and take the square root of 25,000, we get z equals 500, okay? So the distance between them at t equals 2 is 500. That's not our actual answer. That's just the distance between train B, because y represents train B's distance, and train A, okay? I'll always apologize for my rough shot drawings because they're not the most legible, but if you listen to the sound of my voice along with the scribbles, you'll definitely get what's going on, okay? All right, let's move on. Therefore, we can go ahead and use the other equation that we're given, and we can just go ahead and plug in the initial condition 2 that we're told. So VB of 2 equals negative 20, all right, because 2 squared times negative 5 is negative 20, plus 120 plus 25, and that's going to give us 125 meters per minute. Okay, so at time t equals 2, the rate of travel is 125 meters per minute. Okay, this is going to be our dy dt. All right, therefore, we can go ahead and do some more plugging in to unlock this guy here. We can plug into this equation, okay? So if we factor out all the 2's, we're left with z. That's 500. Oh, I forgot to mention, this is where the implicit differentiation came in, because we took the derivative of the entire function, but we're taking implicit differentiation is basically an application of the chain rule. So here we took the derivative of z squared, okay? So we took the derivative of z with respect to z, but we're really taking the derivative of everything with respect to time, so we can't just forget that. So we have, this is our outer function, z squared, but our inner function is z. So we're taking dz dt. We did the same thing here. We took the derivative of x with respect to x, and that gave us 2x. Okay, but now we have to take the derivative of x, which would be our inner function with respect to time. Then we also took the derivative of y with respect to y, and from y squared that yielded 2y. But now we have to go and take the derivative of the inner function, and that's the derivative of y with respect to time, okay? All right. This is definitely not apparent to a lot of people, but like I always say, with several problems, it'll become more obvious as to why you need to do that, because we don't have all the same variables, but we still need to unlock the derivative of this, Pythagorean theorem, okay? But what we can do is eliminate 2's, like I said previously, and plug in our value for z. What we're trying to figure out is dz dt, so that's going to remain a mystery for a little bit. But we know our x because a previous set of flashcards presented a problem where you were told that x, the distance at 2 t equals 2 minutes is 300 meters, so that we know, times 100 meters per minute, because our dx dt at 2 is 100. Okay, our change in distance over a change in time is 100, and this is specifically the change in distance in the x direction or the horizontal direction. Then this problem stem tells us here that, our y, our vertical distance that b travels is 400. And then we just went ahead and figured out that at t equals 2, our dy dt is 125 meters per minute. So 125 meters per minute, we went and plugged in here. Okay, just stick with me on this. You'll gain more clarity later. Therefore, we can combine everything again. 300 times 100 is going to give us 30,000. 400 times 125 is going to give us 50,000. And if you're not clear on this because you're not a savvy multiplier like myself, I'm not the greatest multiplier. Well, 400 times 100 equals 40,000. And then, you can look at this as taking a quarter of 40,000. That's like 10,000. So 25 times 400 would give you 10,000. And 10,000 plus 40,000 is 50,000. So we just add that up. You can eliminate some zeros. And 800, what you can do is do 80 divided by 5, and that's going to give you 16, and then you have the 0 left over, so you can write that in. Or a lot of people know that 800 divided by 5 is 160. And then our units are meters per minute. Okay, so the final answer is that the rate in meters per minute at which the distance between A and B is changing, this Z distance is going to be 160 meters per minute. I know this is probably uncomfortable for a lot of people because it takes pulling from a lot of knowledge. This is where all your math, all your years of algebra and, calculus kind of come together, and you have to kind of synthesize your own solution. It's not so obvious anymore. All right, so this definitely separates the pros from the cons. I don't know how you would say that, but everyone can be super, super good at this type of problem.